So you heard Elon Musk's recent heads up, right? Pretty stark stuff about quantum computers potentially upending everything.
Yeah, and us supposedly being caught completely off guard, it definitely raises some eyebrows.
Okay, let's unpack this because that's exactly what we're here for in this deep dive.
Right. We're going to sift through the source material you shared, Elon Musk's thoughts on this.
Yeah, and pull out the essential insights you need to know.
Exactly. Now, we know everyone tuning in has different levels of tech background.
Yeah, some of you are probably deep in the code, others just curious. No sweat.
We're going to try and skip the super dense technical jargon.
And concentrate on the big picture, what really matters for you.
And the central question, really, based on these excerpts, is what are the key potential impacts of quantum computing that you should be aware of right now?
Right. We've got this transcript of Musk laying out his perspective, and it presents this fascinating duality.
Yeah, on one side, you got this almost unbelievable potential for transformation.
But on the other, there's this undercurrent of concern, this feeling that we might not be ready.
Those two viewpoints definitely stand out. So where do we begin to make sense of all this? Maybe how they actually work.
Sounds like a plan. So forget about the computer you're using right now. Regular computers use bits.
Simple on or off switches, 0 or 1.
Exactly. Quantum computers, though, operate on a totally different principle with things called qubits.
Qubits, right. And these can be a 0, a 1, or
Or both at the same time. It's called superposition.
like a spinning coin. Not heads, not tails, but sort of in between.
Yeah, that's a good analogy. It's in this strange in-between state. And that's like what a qubit is doing.
And this fundamentally different approach isn't just a quirky science fact, is it?
No way. It's the key to unlocking computational power that could, well, revolutionize fields from medicine to material science.
We're only just beginning to grasp it, really.
And this ability to exist in multiple states simultaneously, that gives them a huge advantage for certain calculations.
It does. And it gets even more intriguing, or maybe weirder, when we talk about entanglement.
Ah, yes, the spooky action at a distance. So entanglement is when two qubits become linked.
Linked so they instantly mirror each other, no matter how far apart they are.
Yeah, Musk uses this analogy. Imagine rolling dice on opposite sides of the planet, and somehow they always land on the exact same number.
That kind of freaky connection.
It is. And it's what allows quantum computers to tackle problems that would keep regular computers busy for, like, thousands of years.
As the source highlights.
Oh.
Not ideal, as Musk says, but incredibly powerful.
Precisely. This potential speed advantage is a major reason for both the excitement and the apprehension.
So, while this spooky action and superposition offer incredible potential, building machines that can reliably harness this stuff.
That's a monumental engineering challenge. Absolutely.
Yeah.
This isn't like upgrading your phone.
Not at all. The source makes it clear. These quantum machines are incredibly sensitive, fragile.
They make errors easily, and correcting those errors is a huge hurdle for researchers right now. They're delicate things.
Yeah, imagine trying to perform incredibly delicate surgery where the slightest vibration could ruin everything. That's kind of the level of precision needed.
And they need extreme conditions too, right? Like super cold.
Exactly. Extremely precise and very cold environments, often near absolute zero temperature. Just maintaining that stability is a massive engineering feat.
And it's not just keeping them chilled. Scaling up by adding more qubits, which you need for more power.
That introduces a whole new level of complexity. It's not like just adding more memory to your laptop.
No. The source uses a fantastic analogy here, comparing it to juggling flaming swords.
In a hurricane. Sounds about right, actually.
It really highlights how delicate and interconnected these systems are.
Definitely. And on top of that, the sheer expense of building and maintaining them limits access.
Yeah, mostly to major corporations and big research institutions right now.
So to be clear for everyone listening, your quantum computer isn't streaming your favorite shows anytime soon.
Not gonna happen. The source emphasizes that right now these machines are designed for very specific, very complex problems.
Things like breaking incredibly tough codes or doing, advanced mathematical calculations.
Not your everyday email and homework tasks.
That's an important distinction. But even with these limitations, the potential game-changing applications in the future, that's what drives the interest and the anxiety.
Okay, so with that foundation, let's dive into some of the truly revolutionary ways they could impact our world.
Right, this is where it gets really interesting, as you said.
Let's talk game changers. First up, cybersecurity. The source paints a pretty concerning picture here.
Yeah, what's fascinating and worrying is the potential for quantum computers to just break current encryption methods, make them useless.
The security that protects everything. Online banking, health records, private messages.
All of it. It relies on math problems that are just too hard for normal computers to solve in any reasonable time frame.
Like longer than the age of the universe sometimes, right?
Exactly. But quantum computers, in theory, could crack those codes almost instantly.
Like snapping a twig, as the source puts it, that's not just a minor security flaw.
No, it's a potential collapse of our entire digital security foundation.
Yep.
Governments are understandably scrambling to develop quantum-resistant encryption.
But the source suggests the tech is advancing so fast that our defenses might already be behind the curve.
It feels like trying to build a stronger lock while someone's already picking the old one in seconds, doesn't it?
Yeah, it really does. Raises big questions about preparedness and timing.
Definitely. And beyond cybersecurity, the source points to huge potential in healthcare and substance creation.
Imagine speeding up, testing new molecules, discovering new medicines, cutting down years and billions of dollars to, well, much less.
Quantum computing could let us simulate how molecules interact in ways we just can't easily do now. It sounds incredibly promising.
It really does. Then you throw artificial intelligence into the mix.
Which already needs massive data and computational power.
And combining it with quantum computing, the potential is exponential.
We're talking about AI that could learn, break codes, make decisions at speeds we can barely comprehend.
And as the source points out, there aren't many established regulations or limits in place for that kind of powerful AI yet.
Power without clear boundaries, yeah, put like that.
It's enough to make even the folks building these things admit they don't fully grasp where it's all headed.
And that warning about it potentially altering our very reality? It sounds dramatic, I know.
But when you consider machines that can fundamentally change how we even approach problems, how we think,
Yeah.
it gives you pause.
It challenges our basic understanding of cause and effect, logic, truth, as the source suggests. It's deep stuff.
And it doesn't stop there. Materials, science, and energy, too.
The ability to simulate materials at the atomic level before you even make them.
That's a real game changer. Think potential breakthroughs in batteries, superconductors.
Even entirely new kinds of materials we can't even envision yet.
This could have huge implications for clean energy tech, right? More efficient solar panels, tougher wind turbines?
Potentially, yes. It could revolutionize industries by allowing us to design and discover materials with totally unprecedented properties.
Okay, now all this potential isn't just happening in a lab somewhere in isolation.
Not at all. The source emphasizes this is a full-on global race for quantum supremacy.
It's about power and influence on a global scale. Countries are pouring money into this.
Absolutely. The source mentions the big efforts in the US. Google, IBM, Microsoft are all major players.
Right. Google's claim back in 2019 about achieving quantum supremacy with their Sycamore chip. That made waves.
They did. And this isn't just about national pride. The first nation to really achieve usable quantum supremacy could gain huge advantages.
In intelligence gathering, financial markets, future tech development, it could shift the global balance of power significantly.
IBM is also pushing hard, with their roadmap aiming for more practical quantum computers fairly soon.
And you can't ignore China. They've made some serious moves, like that quantum satellite sending encrypted messages from space.
That definitely got everyone's attention. And it's not just the superpowers.
No, Australia's investing heavily. Canada has a growing scene, particularly in Quebec.
It shows how widespread the recognition of this technology's importance is.
So let's clarify this quantum supremacy idea. It sounds like science fiction.
Well, it's a real objective. As described in the source, it's the point where a quantum computer can do something, anything really, that the fastest classical supercomputer simply cannot do.
Even if that task isn't immediately useful.
Exactly. Reaching that milestone is huge for prestige, but more importantly, it signals a massive leap in capability. It opens up entirely new possibilities.
And the first to get there, they don't just get bragging rights.
No, they potentially gain a massive edge in influence, defense, data, and, well, a lot of economic power.
But it's crucial to remember, as the source also points out, reliable, widely applicable quantum computing.
That's still some way off. Despite the progress, these machines are still sensitive, need special conditions, prone to errors.
Right. So there's hype, and then there's the current reality.
But even with those limitations, there's this silent march happening.
Steady progress, maybe not front page news every day, but it's definitely moving forward.
The source uses that great analogy, turtle pace, not cheetah sprint. Error rates are slowly coming down.
And the chips are getting more sophisticated.
So while we might not see quantum computers in, your pocket anytime soon.
Predictions suggest it could start significantly impacting major industries by the early 2030s.
So those initial real-world applications in the nearer future, probably the advanced stuff.
Like climate modeling, molecular testing, the things we talked about. Not your next smartphone.
Precisely.
Huh?
But the long-term potential to fundamentally reshape sectors like banking, healthcare, data security, AI training, it's undeniable.
And ultimately, this will impact everyone's lives in some way.
For sure. It could lead to real shifts in the job market, the skills needed.
And just the general pace of societal change. It's not just a new tool. It could really transform how things operate.
Indeed. So bringing it back to that initial warning from Musk,
The source definitely highlights the potential for massive disruption.
and that feeling that we as a society might not be fully prepared for all the implications.
Okay, so key takeaways for you listening. These quantum computers have truly unique, kind of mind-bending abilities.
But there are very real limitations and challenges right now. They're not magic boxes yet.
And the potential for profound future impact across a huge range of industries, maybe even our understanding of reality itself, is immense.
Which leads us to a final thought for you to maybe mull over.
Is quantum computing our greatest potential achievement, unlocking solutions we can't even dream of now?
Or could it also pose, significant, maybe even existential challenges?
And will its arrival be this slow, gradual evolution we can adapt to?
Or could it be a sudden upheaval that dramatically reshapes the world almost overnight?
Definitely something to think about. We'd encourage you to keep exploring this fascinating, fast-moving field.
Yeah, form your own informed perspectives. The journey of discovery in quantum computing is really, truly just beginning.